Thank you very much, Klaus-Peter. Let me first share my presentation, and then if time allows, I will also bravely attempt to make a live demonstration. First of all, happy National Day for all of the Romanians out there. Today's for Romania is like the Bastille Day in France and the 4th of July in the US. So this is a pretty important day. Usually people go and have fun, eat, or present at the DDI conference, depends on the on specific hobbies. So my presentation today is about StatConverter. It is a statistical conversion tool using the R package DDIwR. And I will let you know slowly about all of the things you need to know. So for data analysis, we obviously need specialized software, and proprietary such software, has been developed over the years, and we've been all trained in one or the other of these software, namely SPSS or Stata or SAS. Depends on where we had our training, and also free and open source software like R, which is my main data analysis software these days. But none of these software is actually suitable for long-time preservation, and this conference is especially dedicated to data documentation for long-term preservation. And to have this solved, not using proprietary software, it's not that proprietary software is bad. It's just that proprietary software changes over time. And 50 years from now, we are not certain we are going to use SPSS anymore, or Stata or SAS, or even R. They change over time. So in order to have our data ready for analysis 100 years from now, we need to make it into an open format, which is suitable for long term. And for this, we have the DDI, especially the XML, which is a text file that is platform independent. It can be read by any software and so on. Of course, this is known by most participants at this conference, but I'm also telling this for the viewers in the YouTube later. Converting between all of these formats has been a challenge. Some researchers use SPSS, some use Stata, some use SAS, and usually these kinds of conversions probably most of the times go through Excel, and then each, depending on the software, have their own setup scripts and define variables and labels and stuff. It is also possible to use commercial software, like, for instance, StatTransfer, which is one of the most known, to transfer between commercial software. There was also Sledgehammer a couple of years ago. Not sure what happened with this software. It simply disappeared. It was quite fashionable at some point. But those are commercial software. What I thought was missing from the scene is an open source approach using the so-called FOSS software. Because we need, actually, in a world of open science, of open data, I think we need to have this kind of software available. If users want to use a commercial software, that's fine. But otherwise, having an open source alternative, I think it is an approach that will happen more and more in the future. And this is what we aimed to have an alternative to StatTransfer in an open source world, which we call StatConverter, actually. First of all, about the R package DDI, because StatConverter is not a standalone application, as I will tell you later. It relies on R, and on R being installed on the computer. And R as a software being installed, it's dependent on other contributed packages, among which this DDIwR, because it's not part of the R suite by default. But it comes with a base suite of packages, and then there are contributed packages like this, which sit on top of the base packages. This is the DDIwR package, which itself depends on the number of other packages, among which the declare the Haven. Haven is actually one very good software that it relies upon. Admins can read R to have all of this communication. Haven is doing the heavy lifting, but Haven is actually employing the Evan Miller's readstat.c library to do all of these conversions. Otherwise, Haven is the R interface to the readstat library. And this is what DDIwR is itself. Through Haven, it's an R implementation of that library. And it also uses this HTTP-UV package, which is very important because, as I will show you later, the user interface we are building on top of R is communicating with R using WebSockets. And HTTP-UV is the package which starts an R web server, and then using the WebSockets, we are communicating with R and giving it the actual conversion commands. But otherwise, users wanting to convert between one software to another, it's not mandatory to use the graphical user interface, of course. These things can be done through command line as well. And that's very convenient because command line can be used either in a standalone computer or, why not, in a server. So having such a package like DDIwR allows people running services on a server to convert between software formats on demand, which I think is pretty fancy. Among the features of the DDIwR packages is that it gives a robust solution to the problems of categories and missing values in R. These two things were not exactly well defined for the social and behavioral sciences until the suite of packages that I wrote appeared on the scene. It's capable through the readstat library to read the metadata from the social science datasets and translate those data into an R list, which is a pretty close, pretty compatible object with the DDI XML structure. Of course, it imports and exports from all of these commercial software, SPSS, Stata, and including DDI, which is something I'm very excited about. And it's only about DDI codebook. In the future, we are committed to develop for the DDI lifecycle, but so far it's about DDI codebook. And it also creates setups and syntax file to allocate labels and missing values if the data is imported into all of these software from a CSV file. To do the import-export from the command line, it's just as simple as that. This is reading, for instance, a test SPSS file, and it's converting it into an R object. And we can actually read all of the metadata about the variables and labels from that object, or we can just say get metadata from the original SPSS data file. It doesn't matter. Get data metadata is agnostic to that. Or directly convert from one software to another, in this case from SPSS to Stata, using the function convert again. From this software, and we can just simply say to Stata, and it will create a similar file with the extension DTA for Stata. Or we can just specify a path and a different name for the destination file, and it will convert from that to that. And so it's as simple as that. And the same goes with SAS, the same goes with R, the same goes with DDI. The command is similar. To create setup files, it reads this kind of SPSS file like that with all of the variables and variable labels and value labels and missing values as well. And it creates a do file which can be read by Stata to allocate variables and labels and missing values. And the other way around, we can read a Stata file to create an SPSS syntax file, an SPS. Similarly, we can use the DDI codebook, the XML file, to actually create the syntax files. All of those are very compatible with one another, right? And this will simply create all of the software. So it has this function setup file has a argument file, which is, if is not specified, it will create syntax file for all of the software types at once. I think I have time, but command line, it's not everyone's cup of tea. And instead we have opted for this graphical user interface, which sits on top of R, that uses Node as the base and Electron to build. I will tell you about it more. And together they form the StatConverter software, which I will demonstrate later. And this is basically the substance of the presentation today. And our aims when we designed StatConverter left from some requirements. It has to be easy to use, easy to develop. It has to be cross-platform, to work on new and old computers alike, to be easily extensible and have a potentially large contributors pool. JavaScript being one very good and very well-known development language. Node.js allows people, it's very well-known, it's used everywhere basically these days. It allows people to write server-side high-performance network applications, and Electron actually is the framework which under Node allows us to develop desktop applications using HTML, CSS, and JavaScript. So we are actually developing an application which is similar to a web page, but without a web browser, because it has its own web browser embedded in the application. And the goal is to write once and develop everywhere under all operating sources, to avoid writing specific platform operating code. And JavaScript is standard and it's present everywhere. So it can have binaries built for Windows, Mac, or Linux, it doesn't matter. This is a screenshot of the input screen, which I will demonstrate. And it has some inputs like here and outputs. Optionally, if the input is encoded in some other format, we can choose that. And similar to stat transfer, we have a variable selection, or we have a case selection, which uses the R language. There is no sense to develop another language when we have R as well. And optionally set some settings which go to the Haven package and further on to the readstat library. And towards the end of my formal presentation, this is an open source software which is present on GitHub here, and also binaries will be uploaded in the future once we are certain they are stable and don't produce anything wrong. They will be uploaded here on the GitHub.io StatConverter. And that's the end of my presentation. For the next 2 or 3 minutes, I think I can share the entire screen now in order to switch between software. And this is the actual software. It looks like that. So basically what this is similar to a web page, but it doesn't have a address bar or something, but this is actually a web page, and this is HTML, right? And let's say we want to transfer from SPSS. This is the actual ESS9 for Germany. I chose that because it has a lot of diacritics and umlauts and stuff in order to test encodings. And I will browse to that, select the output, and click convert. And that will create a copy of the entire data frame here. Should be, right? create a copy from SPS to Stata. Optionally, if we want to select some variables, we have a search here. Let's say all of the variables that contain me, or all of the variables which contain no, something like that. It searches through the various modes. We can click either to select or deselect. We can deselect all or select all. And all of the variables contain no, for instance, we want to drop or we want to keep. So it, or pattern starting with, ending with, using like this. This is starting with, let's say E, we want to drop. Okay. No, ending with E, sorry. This is ending with E, right? And starting with E, to drop as well, keep. And similarly for cases, we want all cases where, I don't know, NetUseSoft. What is NetUseSoft? We can look at this, and it has all of these variable label, value labels and stuff. And we want to keep all of the data where NetUseSoft is equal to 4, let's say. And use this, NetUseSoft equals to 4. And that's basically it. We convert it again. Let's use a different name. 2, convert, and that will convert a different version of the data file. It will appear here. And this is 11.6 megabytes. This is 1.2 megabytes, simply because we have selected aggressively between cases. And finally, I will only demonstrate DDI codebook. First, by not choosing to embed. Okay. Convert, and that will create an XML file here. And I will look at the XML file structure here. And this is basically the DDI codebook with the variable description, data description and stuff. This is all done automatically. It's DDI 2.5. And optionally, if we want to embed the data, this will get updated. In the notes session, we have this, and this is just to demonstrate that the DDI codebook XML file can actually contain data and metadata. And the DDIwR package knows to look at this notes section of the file description. And when it reads start data, it means that it has the CSV data inside, which means the XML file is now portable, including data and metadata. So they travel together, literally travel together. So that was my presentation for today. I hope it was interesting. Thank you very much.